In this video, I will be explaining some questions concerning linear and quadratic systems. A linear equation is graphed to the right. Which of the following equations combines with the graphed equation to create a system of equations whose solution set is comprised of the points -1, -5, and 3, 3. Now, if you want to check for those points in your solution in the graph, that's good, but it will waste you some time, because the question is asking you for those points which should be included in this line. Now, what you can do directly is substituting one of those 2 points in the following choices. So let's take choice number A. You have -5, is it equal to -1 squared minus 6, and you will get -5 equals to -5, so choice A is still acceptable. Going to choice B, so you will have -5, is it equal to 6 minus -1 squared, and you will get -5 different than 5, so choice B is not acceptable. I will cancel it out. Going to choice C, -5, is it equal to 4 minus -1 squared, and you will get -5 different than 3, thus choice C is also rejected. Last but not least, choice D, -5, is it equal to -1 squared -4, that's -5 is different than -3, thus choice D is also rejected. And my only solution would be when it is A, the choice A. But if you want to be sure of that, just take the point 3, 3 and substitute it in the equation A. You will get 3, is it equal to 3 squared minus 6, thus 3 it's equal to 9 minus 6, and 3 is equal to 3, which is okay, thus my only solution is A. Let's solve now question number 2. Which of the following represents all solutions xy to the system of equations shown below? So to solve such a system, what we need to do is put y equals to y. So x minus 2 is equal to x squared minus x minus 5, and take everything to one side. You will get x squared minus 2x minus 3 is equal to 0. Now, after factorizing by using delta or some product or even your calculator, you would get x minus 3 into x plus 1 equals to 0. Thus, x equals to 3 and x equals to -1 are my two solutions, and they have y's as well, which are equal to, so 3 minus 2 is equal to 1, and -1 minus 2, that's -3. Thus my pairs are 3, 1 and -1, -3, and my solution would be choice D. Let's solve now question number 3. Which of the following represents all solutions xy to the system of equations shown below? Take this first equation and write it as y equals to -x plus 6. Now take both equations and write y equals to y. You will get -x plus 6 is equal to x squared minus 2x minus 6. Taking everything to one side, you will get x squared minus x minus 12 is equal to 0, which can be factorized into x minus 4, and x plus 3 is equal to 0, which has the roots x equals to 4 and x equals to -3. Remember, those are the x values, they still have y values. But looking at the solutions here, we have 4 and -3 as choice B only. As for question number 4, a quadratic equation is graphed to the right. Which of the following represents all solutions xy of the system of equations created by the equation of this graph and the linear equation y equals to x minus 7? Notice here the equation for this graph is written down below, so I can use this and write y equals to y. Thus x minus 7 is equal to x minus 6 squared minus 3. Now Distributing x minus 6 squared, you will get x squared minus 12x plus 36 minus 3, and on the other side you have x minus 7. Taking everything to one side, you will be left with x squared minus 13x plus 40 equals to 0, which can be factorized into x minus 5 into x minus 8 equals to 0. So my solutions would have the combined solutions, or the paired solution, as 5 comma some value a and 8 comma some value b. My only solution for this exercise would be part B. Last but not least, exercise or question number 5. If a comma b is a solution to the system of equations above and a is greater than 0, what is the value of a? Here we are searching for the value of a, which means I'm searching for x. Thus, what I need to be doing here is to write the second equation here as y equals to 3x. Then substituting this x instead of the y's here, you will get minus 7x squared is equal to 3x plus 5 into 3x minus 5, which is equal to negative 7x squared, and this is equal to 9x squared minus 25, just by distributing this part. Now, what we will be doing next is to isolate the x, which means take this negative 7x squared to this side and negative 25 to the other side. You will get 25 is equal to 16x squared. Divide by 16 on both sides, you will get x squared is equal to 25 over 16. And in order to solve this, you will get x equals to plus radical 25 over 16 and x equals to negative radical 25 over 16, which is equal to 5 over 4 and negative 5 over 4. But remember that a should be positive, thus this is rejected, and my only solution is 5 over 4. So I will write here 5 over 4. Thank you for attending this session.